video, we will continue our charting primitives. Two are already covered in our previous video. In today's video, we are going to cover rest 3, bar charts, pie charts and area charts. Bar chart uses one or more proportional sized rectangular elements which are called as bars to represent specific data values. Now these bars or rectangles can be either justified as horizontally or they can be placed vertically. So these bars when placed vertically are actually called as columns. When they are placed horizontally they are called as bars. Say for example, consider this particular bar chart. In this bar chart, x-axis is showing number of coffee cups that have been consumed and y-axis is showing the coffee consumption over different years. So here there are multiple bars which are placed side by side to illustrate the relative difference and the impact of this chart directly relies on the comparison. Say for example, from this particular chart where blue bars are actually represented for a country, Austria. So in an Austria country, the number of cups that are consumed of coffee are maximum in a year of 2012 as compared to the year 2008. These bar charts are very great for at a glance comparison. One axis sets the categories. Your y-axis is showing a category that is in year 2008 to year 2013. These categories may be the dates or a series of months, or it can be in quarters or in the form of locations or in a form of places like sales office and marketing department and so on, which shows some relevant group. While another axis, which is x-axis in our case, which shows series of values of a single unit of measurement. Say for example, number of cups or number of employees. All these are measurements which are often in an ascending order from left to right and from top to bottom arrangement. The scale of measurement may vary. In some cases, scale might start from 0 and go up to some value n. But in some cases, we can directly start from a number like say 1,00,000. There do exist other two variations of bar chart that are called as grouped chart and stacked chart. So let us see what is grouped bar chart. In a grouped bar chart, we place bars which is representing members of a subcategory adjacent to each other in a form of group. Say for example, we are having the same chart over here which gives annual coffee consumption by country. In a previous chart, we have only data of an Austria company, but here two more companies are added like Bulgaria and Denmark, and their annual coffee consumption yearly are grouped together and placed beside each other so that we can compare their values in a category. A grouped bar chart adds another perspective to data. For example, here you can also deduce an information that Austrians drink much more coffee year by year as compared to other European countries like Bulgaria and Denmark. So they are actually giving a hike in the consumption of coffee year by year. As the year passes, the consumption also increases in Austria as compared to other European countries. Another type of bar chart is a stacked bar chart. They also works with subgroups, but instead of clustering or grouping them together and placing adjacent to each other, their cumulative values are placed in a single subgroup. So they do also represent the cumulative value as well as their individual total value. This is the data of e-book sales by its genome, which is given turnover in millions. So light blue is actually literature books, purple are the western books, general books are represented by green color, crime books or crime mystery books are represented by yellow color, romantic thriller is represented by orange, and dark blue is for sci-fi or fantasy genre books. Given for 2010 and 20, from that we, we have estimated for 2030. So obviously you can compare that sci-fi books sale has been increased. We do not see so much increase in western type of those purple books, and those green books are the general books whose sales is not increased over the span of next 30 years. So this is the insights that we gain from given stacked bar chart. Your subgroups are differentiating some manner, such as varying colors or patterns can be used to create a subgroup, which can be either identified by the legend. Legends are nothing but those notations that are written towards the right of it. Say, for example, light blue is literature, green is general, dark blue is sci-fi. All these are called as legends. Now, along with their individual value, the aggregated total is also represented by stacked bar chart. So all collective 2010 sales is approximately 110. 2020 approximate collected sale of ebooks is approximately 130 in millions. So I mean, not only individual levels are giving us an individual information, but collectively cumulative values of subgroups are also depicted in a stacked bar chart. We cannot only represent bar charts in a 2D manner. Obviously, bar charts can be depicted in a 3D style. So these charting elements are combined with three directions: x-axis, y-axis and z-axis, which gives rotation, pitch and the depth or a yaw of a particular bar. These bars are not compulsorily needed to be in a rectangular form. We can use any 3D form to represent the bar charts in a 3D form. Here this is the variation in a cone side or triangular side 3D bar chart. An alternative to our bar chart, which is visually very compelling, visually very appealing, but this must be labeled properly to avoid any misunderstanding of data. Plus, it doesn't give us the visual volume of any data. For example, the cache over the top of the cone is 26.76% of data, while the light blue, the second one from the bottom, is bonds, which is worth 18.39%. So obviously the volume covered by cache is more than the bonds, but visually it appears like cache is having less ratio as compared to bond. So be very careful while selecting the bar chart, any in different shapes. Next is the pie chart. Pie chart is a circular graph which is composed of separate portions, which is also known as a sector, to represent a relative data set. So size of a sector is directly proportional to its the data series. Say for example, this is the popular breeds of dog, where blue color are Labradors, orange colors are German Shepherds, yellow color is Golden Retrievers, then green are Peggies, and 10% purple are the Bulldogs. So these are nothing but popular breeds of the dog around some collected data. So here the data series in a bar chart are open-ended and they do not need to match any particular total. So while we are actually interested with the total value of a particular data set, then we must either go with pie chart as compared to bar chart, because pie charts are closed. They are giving us the complete data series in a form of percentage as 100%. So they are great for showing simple relationship between various data segments. In a pie chart, when they are labeled with the data values, it gives us the hard number as well as usual percentage. The proportion of the size of a sector is determining the data value is divided by the total of the value and then multiplied with 100. So in the next slide, we are going to see how any data which is given for some data set is how they are converted into percentage, and they are how shown by sector wise in a pie chart. So percentage, whatever we have got in its data share, is multiplied with 360 to get an area over a circle. Consider this data. There are 4 directions, and the data of each direction is north 200, south 125, east 175, and over the west it is 150. So in total we have data for 650 elements. Now how to show or how to draw pie chart of this particular data. So data value total is 650. So we divide each value with the help of 650, which will give us segment percentage. So 200 out of 650 is actually 30.8%. 125 out of 650 is 19.2%. 175 out of 650 is giving us 27.9%. And 150 out of 650 is 23.1%, and total 650 is 100% of data. So this is the share of each section over the circle. Now in a circle, each slice is of some particular angle. Say some broader slice is of say 125 degree angle, and the thinner slice is only sharing 6 degree of circle. So how to get those degrees from this percentage? For 100% we have total 360 degrees. So we can draw one arc or slice of a circle of 111 degree and call it as a slice representing north. Then we will draw a slice of say 69 degree and represent it as a south slice. Pie charts are actually frequently displaying both raw data and percentage data. You can directly either show that data in a pie or a slice itself, or you can add an animation or an action. Say for example, whenever the mouse button is taken to some particular slice, then a text box or a pop-up will appear which will give an exact value over it. So this is the representation of north, south, east and west, and sharing their own data. They are actually labeled with only percentage, but hovering or clicking of particular size will give us the actual data value. Say for example, west it is 150. To emphasize a particular data point associated with pie slice, we can either move it from the center and explode it. Okay, so while say for example this is a 3D pie chart and I want to see some insights of say yellow part, so I will click on that part and the slice will come out to represent effectively in a 3D fashion. So as of the bar chart, 3D pie charts can be also used, which can be tilted in any orientation. This is the tilt towards the left. I can tilt a pie chart as a vertical point also. So they are actually rendered with shading and shadows. It is also helpful to drill down into particular pie segments. Say for example, in this the larger pie segment, there are only 5 sections where north, south, east and west data is only present. But there is one more section called as other. While clicking on other pie will pop up a new pie which is showing 2 different regions. So this is called as pie of pie type chart, where percentage value of an entire child pie is equal to the parent child slice. So 19% is now further divided into 6%, 3% and 9% respectively. So the collective percentage of a small pie is the actual percentage of original pie segment. This is called as drilling down the pie or pie of pie chart. In a pie of pie approach, it breaks out the sector out of more detail only when required. So this is just avoiding very small chopping of a pie, which is just avoiding so much crumbling in a single chart. So series of small slices are created. One variation of pie chart is a donut chart. In a donut chart, they are circular charts which are used to represent multiple series of data. So this is an example which is showing distribution of seat as well as distribution of votes. Outer ring is a distribution of seat and inner ring is distribution of votes. Now these seats are divided. For an outer ring, for a light blue color it is Democrat Party and for purple color it is Republican Party. Democratic Party is securing more votes as compared to its seats, and Republican Party have secured less number of votes as compared to its seats. The donut chart uses multiple rings to display range of related data. Another type of circular chart is the polar area diagram, which equates the data value as a distance from center of the circle rather than the percentage degree of a circle. So instead of covering the percentage degree, it is measuring the data from center to outside. These graphs are often used by meteorologists to find out the wind speed in all the directions. These diagrams are also called as windrows diagram. In this polar chart, wind is coming from northwest side is the strongest. Actually, over this circle, the top is the north, bottom is south, towards the left is east, and towards the right it is west. And wind that is coming from all the direction of a particular location is being denoted by a rose diagram, wind rose diagram. Let us deduce what is information that is being conveyed from this particular chart. So this is the slow polar chart. In this gray area with a red outline is the people who work, yellow are the people who eat, and pink are the people who commute, and grey people watch TV while blue people sleep while they are free. So as you can see, the largest amount of people when they are free they eat. The next is people who work, and then are those people who socialize, then followed by those people who watch TV, and those are the lazy ones who sleep. So they are actually showing the distance from center to the outside of circle by showing its effect. Next type of chart is area chart. Area charts are basically line charts where the area between the line and the chart is filled by some color or some pattern. So if you notice carefully, if there is no shading or filling of this particular portion, basically this is a line chart. So in a line chart, if the area between the line and the graph axis is being filled, it is called as an area chart. This is an area chart which is showing the monthly coffee production of a place, Papua in New Guinea. It is basically emphasizing the area which gives a focus to the volume of the data. The simplest area chart depicts a single set of data points. But if we have multiple data points, we may have multiple areas shown in a single chart. So they come into their own when multiple data series are displayed over the area chart. They are placed side by side for comparison. But only that one data series won't hide another data series. We use transparent filling colors so that the data will be visible for each input. Here the blue area chart is for Papua New Guinea, where red area chart is for Brazil in a production of coffee monthly. When cumulative data is important, another approach of area chart is to use tagging with area chart. One area chart is placed over the top of another. So relative data values of various data sets are actually displayed over the total. So here stacked area chart will enable us to quickly grasp overall trend as well as specific data change. This is the production of rare material from earth called as rare earth oxide from the span of 1950 to 2000, and what is the production of other countries is being depicted by yellow area. The production of USA actually started right from mid of 1960 to 1970 and expanded in the 1990s, whereas China's production started later of 1980s and it hiked all over. So we call initial era as Monocyte placer era, then we have mountain pass era, and finally we have Chinese era of earth oxide production. In today's video lecture, we have covered what is bar chart and its variation, pie chart and area chart and its variation. We also must know what kind of charts will be used for what kind of data sets. Thank you everyone for watching this video. This is Munira Dupia.